All right, let's talk about something you probably see every single day: boxes. I mean, they're everywhere, right? They bring us our food, our gadgets, pretty much everything. But have you ever actually looked at one? Today, we're going to do just that. And trust me, you'll uncover some seriously cool engineering hidden inside the plain old box.
So, our journey starts right here. This is a corrugated mango box from a company called Boxpool LLP, and it costs about 45 rupees. Seems simple enough, but this one box is going to be our key to unlocking a whole hidden world of design.
And that's where the real mystery begins, right? I mean, why isn't it just a box? What's so special that it's specifically for mangoes? And what are you really paying for with those 45 rupees? It's way more than just some folded paper. And we're about to find out exactly why.
Okay, so the first clue is hiding in plain sight, right in the name, corrugated mango box. That word, corrugated, that's everything. And you know, while most of us just say cardboard for everything, in the world of packaging, they are absolutely not the same thing.
Think about it like this. Cardboard is just a single, thick sheet of paper, like a cereal box or the back of a notepad. But corrugated packaging, oh, that's a completely different beast. It's an engineered material, built in layers, specifically for performance.
So here's the technical breakdown. A corrugated board always has 3 layers. You've got 2 flat outer sheets, those are called the liners, and then squished right in the middle is this wavy, kind of curvy layer of paper. That wavy bit has a name. It's called the flute. The easiest way to picture this whole thing, just think of it as a paper sandwich. Seriously, and this simple little sandwich idea is pretty much the foundation of the entire multi-billion-dollar packaging industry.
So, using our sandwich analogy, the outer and inner liners are basically the 2 slices of bread. They give it a nice, flat, stable surface. But the real magic, the secret sauce, is the filling. That's the wavy, arched flute in the middle.
So why is this so important? Well, those little arches in the flute, they act like tiny columns, which creates this incredible strength. It lets the box support a ton of weight, and it cushions whatever's inside from getting banged around. Plus, all the air trapped in those little waves even provides insulation. You get all of that, and it's still super lightweight. It's just a brilliant piece of efficient engineering.
Okay, but we can go even deeper. That wavy filling, the flute, it isn't just some random squiggle. No way! The size and the shape of those waves are a super specific engineering choice. It's like a secret language that actually defines what the box is capable of.
You see, these flutes are labeled with letters. A flute is the thickest one you'll find, so it gives you the best cushioning for really fragile stuff. C flute is kind of the workhorse. You'll find that in most shipping boxes. B flute is great at resisting crushing, perfect for food. And then you get down to E and F flutes, which are super thin, and that's perfect for retail boxes where you need really sharp, high-quality printing on the outside.
And to really put that into perspective, an A flute might be around 5 millimeters thick, while an E flute is only about 1.5 millimeters. I mean, it's a difference that's tiny to us, but it completely changes what the box can do, transforming it from a heavy-duty shipping container into a sleek little retail package.
And that brings us back to our mango box. We can finally answer the question, what makes it a mango box? It's the choice of flutes. It needs amazing stacking strength so it can be piled high on a truck, and it needs good crush resistance to protect those delicate mangoes inside. That very specific engineering decision is what you're paying for.
All right, so now that we've kind of cracked the code of the mango box, let's take a quick look at how this one simple idea, the corrugated sandwich, is used in thousands of different ways across basically every industry you can think of.
Check out this cake box. A little cheaper, you'll notice, at 33 rupees. For a cake, presentation is everything. So this probably uses a thin E-flute to get a really smooth surface for printing, making the box itself part of the whole experience.
Now what about an oil packaging box? More expensive than the mango box, at 50 rupees. This thing has to hold heavy, clunky cans, so it needs maximum stacking strength, and has to be hard to puncture. It might even be what they call a double-wall box, which is exactly what it sounds like. 2 layers of that corrugated sandwich, glued together for some serious durability.
And a pharmaceutical box? Well, the priorities here shift completely. The engineering is all about precision, cleanliness, and building little internal structures to keep tiny, fragile vials safe. It's about accuracy, not just raw strength.
And this logic, it applies to everything. Boxes for hardware, delicate jewelry, biohazards, cameras, gifts, you name it.
Each one is a totally unique combination of those liners and flutes, engineered perfectly for its one specific job. Okay, let's pull back for a second. We've seen the physical engineering, right? The stuff inside the wall of the box. But that's only half the story. The other half of this unseen engineering is the business process that actually turns a client's problem into a finished box.
See, to get to an annual turnover like box pools, somewhere between 5 and 25 crore rupees, you need more than just good box-making machines. You need a rock-solid system. It all kicks off with getting a super detailed order brief, understanding exactly what the client needs the box to do. Every single detail then gets logged into a customer relationship management system, a CRM. And from there, a super strict follow-up schedule kicks in. They often use what's called the 137 rule, contact on day 1, day 3, and day 7. It's this whole rigorous system that ensures a project moves from just a lead to a closed deal, and it's what lets them build a multi-million-dollar business on the science of a paper sandwich.
And that's really the big takeaway here, isn't it? A box is never just a box. It's a piece of purpose-built engineering, both in how it's physically built and in the business system that creates it. Every single choice, from the thickness of the paper to that follow-up call logged in the CRM, is a calculated decision designed to solve a very specific problem.
So I guess I'll just leave you with this question. The next time a box shows up at your door, what are you going to see? Is it just a brown container you're going to toss out? Or are you going to see the hidden sandwich, the secret code of the flute, and that whole system of unseen engineering, both physical and procedural, that was designed to do its job perfectly?